choose the point C, what's that ordered pair? Okay, so the ordered pair is 1, 3. Write the x-coordinate first, y-coordinate second. Okay, so then what's C prime? Okay, we go over 1, 2, up 6, okay? Is it easy to see what they multiplied it by after writing down your points? Yeah, what did they multiply by? 2. They multiplied everything by 2. So that's one way to find the scale factor. Another way you can find the scale factor is using the distance or the length of the sides. From B to C, how long is that side? And then from B prime to C prime, how long is that side? 4. So to get from 2 to 4, what do I have to multiply by? I could even check here. B to D is how long? And B prime to D prime is 2. What do I multiply 1 by to get to 2? There that you can use. So you can use the length of the sides, or you can just pick one point and go to the next point to see what they did as a scale factor. Any questions on finding scale factors? A lot of times, your best bet is to use length of sides because there's going to be more than one transformation that happens other than the dilation. Okay, so use length of sides more often. Okay, remember similar? Okay, here's our symbol for similar, just one squiggly. The congruent puts the equal underneath that squiggly mark. Okay, so similar, we're going, instead of writing ABC is congruent to DEF, now we're going to write ABC is similar to DEF. Okay, so instead of writing a congruent statement, we're going to write a similarity statement. So here it says, what sequence of transformations maps ABC to DEF? So we might start by saying ABC is congruent to or similar to? Similar to DEF. And then we write our transformations. Which one are we starting with then? ABC. Okay? Even when you have similar polygons, okay, the first thing, this time, I shouldn't have said even, but this time, get your shape to try to be the same size. That's the first thing you're going to want to do. Get the shapes to the same size. And then orientation, and then right on top. Because yesterday we started by getting them to be the same orientation, right? Today, start by getting them to be the same size first, and then get them to be the same orientation, and then you can translate that from there if you need to. Okay, Alex? Why? Because when a dilation not only changes the size, but it changes its location. It may move it closer or further from the origin, and a lot of times, if I just make the size the right size from the beginning, then I don't have to worry about, is there another transformation that I need to do before my dilation? Because a lot of students might say, yeah, I need to reflect this over the x-axis to get the same orientation, right? And then, well, it still wouldn't be right on top of it if I do a dilation because it's over here rather than over here, okay? So let me just, for instance, let me show you. If we do a reflection over the x-axis, 1, 2, 3, 4, 1, 2, 3, 4. Okay, there's our shape. Does it look like if I do a dilation, it's going to be right on top of it? Okay? And that's what confuses students. Now, if I do my dilation of 1/2, it actually would be right on top of it. And it would be perfect. But what confuses students is that, well, I would still have to translate it to the right and down before it's right on top of it. That's what a lot of us think. But if you just get rid of that dilation, do the dilation so they're the same size right away, then it's going to move your shape right away, and all you'll have to do is get the orientation the same, and then maybe translate from there. Okay, so let me show you a dilation first. What might we have to dilate by in order to get it that same size? Are we going to pick a number bigger than 1? No, because that's going to make it bigger. We need to make it smaller, so we have to pick a number what? Smaller than 1. Okay? Remember what I said. Go by side lengths. What side might be a good side to use as a reference? AB. And the reason is because you can count the diagonal length here. It's 2 diagonal length squares. AB is going to be congruent to what side in the small one? Or similar to? DE. And how long is DE in diagonal squares? 1. So to get from 2 to 1, what do I have to multiply by? That's 4. And not divide by 1/2, but multiply by 1/2. Multiplying by 1/2 is like dividing by 2. So either way, if that's the way you want to think about it. So let's multiply by a scale factor of 1/2. Okay? Where's A at? 1, 2, 3, 4, 5, 6. So -6, -4 is going to become what? If I multiply by 1/2. -6, good, is going to become -3, -2. So I go 1, 2, 3, 1, 2. And now that's A prime. Okay? B is at 1, 2, -4, -2. B prime is going to become -2, -1. And C is at -2, -5, -1, and -2.5. Now look at that. Could I move my shape as well as make it smaller? It moves because of what? The dilation. The dilation moves it and makes it smaller. It does 2 things, and that's why dilation sometimes confuses students. And now can you see easily what you need to do next to get it right on top of the other one? So that's why I say do the dilation first. Get it to the same size first because it does 2 things. It moves the shape and it makes it bigger or smaller. In this case, it made it smaller. If I were to now do the dilation up here, yes, I would still get it here, but a lot of times students, once they see this, are going to translate it somewhere. And then that's where mistakes happen. So do your dilation first. That's a great question. Okay, so now after we dilate with K equals 1/2, dilation of scale factor 1/2, what are we going to do to get it right on top of DEF? Reflect over the x-axis. Okay? Because then when I reflect it over the x-axis, it gets to be the same exact shape as DEF. Questions? What did I do here again? I tried something and then I did what? I drew it out so that I could see it, to see if it does what I want it to do. Okay, maybe if this reflection doesn't look right to me, okay, maybe I try my dilation. now the dilation looks good. All I need to do is reflect it, and I'm done. Okay, so draw your shapes out. I want to see that on tonight's homework when you guys do that. Draw it out. We can talk about this one. Okay, this one says, what sequence maps PQR to STU? PQR to STU. Start by writing what? Good. Your similarity statement. That's what that's called. Okay, so we're going to say PQR is similar to STU. PQR is similar to STU. Write your similarity statement first. Okay? What do I want you to probably do first? Get it to be what? Tim? Same. Not orientation first this time. Size. Get it to the same size. Because then that way we can work on the orientation after that. Okay, so same size. What do I have to do to PQR to get it to the same size? Make it bigger or smaller? Bigger. Okay, now we have to figure out how much bigger. How did you figure out by 2, Tim? Yeah. Okay. So you went a 2 by 1, and here was a 4 by 2. So that's about double the size. What I would do, and that's a great way of thinking about it. Another way to think about it, look at side QR. How many diagonal squares do we have? How many diagonal squares do we have in UT? Okay, and that's another way to see that it's double the size. Okay, so first thing is to dilate with a scale factor of 2. Okay, so let's do that. P is going to go to 2, 2 from 1, 1. And it's not going to fit on my graph, so this isn't the best here, but we're going to do what we can. Okay, R is at what? 3, 2. So it's going to go to 6, 4. 1, 2, 3, 4, 5, 6. And then up 4. 1, 2, 3, 4. So there's R prime. Okay, and Q is at 2, 3, so we have to go to 4, 6. So 5, 6. And there is Q prime. Okay. Now we have the same size. Once we have the same size, we can work on the orientation. What might we have to do to get that orientation to be the same? If we rotate it 180 degrees, that's going to put us right on top of STU. Very good. So we're going to rotate 180 degrees. Yep. Yep, very good. If you reflect it over the X and then reflect it over the Y, that would be the same thing as rotating 180 degrees. Any time that you see a 180 degree rotation, it's the same as if I reflect over the X and Y axis. It's the exact same thing. So yes, you can do that. If you would rather do that than the rotate 180 degrees, you can do that. You have to do 2 reflections. Okay, any other questions? Okay, let's move on. And here we go. These are the ones where you have to now actually tell me Which triangle are you starting with, and which triangle do you want to end with? And it's up to you. Because did I say to start with one or the other in these directions? I did not. So now it's up to you. A lot of times, if it's me, I like to start from the beginning, and I like to go alphabetical order, and that's what I'll usually start with. But if you want to start opposite, you can. Okay. But for the sake of just this one practice problem with the whole class, we're going to start with alphabetical order. Start with ABC. Okay. So I'm going to say ABC is similar to, okay, which point is corresponding to A? R. Which point corresponds to B? S. And then C corresponds to T. Okay, and you know that B corresponds to S because if I start at A, I go diagonally. Well, which one goes diagonally from R? S. So I have to go from A to B. I have to go R to S. Okay. Which of the two? I think there might be more than two transformations. But what should be the first thing you should do? Get it to the same size. Good. So Alex, any idea of what we might do? Dilate by 2. Okay, and how did you find 2? Okay, TS and BC. BC is the length of 1. TS is the length of 2. So 1 times 2 gets us to that same length. Okay, very good. So let's dilate with a scale factor of 2. And let's draw out our shape so that we can see what it looks like. 1, 1 is going to become 2, 2. Let's see, B is at 1, 2, 3, 3, 2. So 3, 2 becomes 6, 4. That is B prime. And C prime is at, C is at 3, 1. C prime would be at 6, 2. Now we have our shape that's the same size. Well, what might we do to get the orientation the same? Now we got the size the same. Now we want to get the orientation the same so they're both facing the same direction. Same direction. Reflect over X. Alex, you agree? Okay, reflect over the X. If I reflect over the X-axis, it's going to flip it down, and then that would be the same orientation. Very good. So C is 2 away. I go 2 away. That's C double prime. B is where? 4 away, so I go 4 away in the other direction to get B double prime. A is how far from X? 2. I go 2 the other direction. I get A double prime. Do we have the orientation the same now? Yes. So our second step was reflect over the X-axis. Once you have the orientation the same, then you can work on getting it right on top of the other one. And the last thing we might have to do is what, Jack? Well, what are we going to do? Get A double prime, B double prime, C double prime on top of RTS, or RST. Okay? Good. A translation is the only thing that moves it by keeping the same orientation. So we're going to have XY translates to. Okay, so we have to move. If I use A double prime, I have to get it on top of what? R. So we have to move 1, 2, 3, 4, 5, 7. Very good. X minus 7. Y stays the same. I don't need to move it up or down. Very good. Any questions today? Okay, this is what I want to see on your homework. Draw shapes in to see what it looks like. Okay? That way you're working on your transformations as well. All right, so tonight work on H14, please.